Something's really going wrong here. Hello, everybody can actually hear me now. All right, we're off to a fantastic start. But hey, technology is what we know and love and what we spend all our time working on, so yeah. All right. I'm just going to cut all of that start anyway, probably, hopefully. No one will ever see this again. But until then, welcome to the 103rd Melbourne AWS user group. It's April already, somehow again, April, which means that we've now been, this is our 12th or 13th online broadcast. So thank you very much for tuning in. We've got a great night ahead of us. There's a couple of great presentations, even though they're about Python. That's okay. We love Python. It's a very useful tool, and we're always happy to get more presentations about it. If anything, it's probably a little bit undersold, really. But great night coming up, and it's not just strictly Python. There will be a lot of non-Python bits as well. And generally, you know, the information contained will be useful regardless of what language you're using. Let's get through, see if the technology is still working. Looks like the technology is working, sort of. So our agenda for tonight, and I realize I'm looking a little bit blurry there. Oh no, I won't do that. Our agenda for tonight, this is the introductions that I'm running through now. Then we will have a news segment from Ian and Guy, our regular hosts. Straight up after that, our first presentation for the night from James on event-driven data using AWS API WebSockets, API Gateway WebSockets. I haven't really had much of a chance to play with API Gateway WebSockets myself, so this is something I'm really looking forward to hearing about. And then straight after that, Mike will take us through an introduction to Chalice, which is another great one that I haven't really had much of a chance to play with yet. So I'm going to be doing a lot of learning tonight, and I hope everybody will join me in that. Because we encourage you to ask questions throughout the night. Anytime you have any questions of our presenters or of myself or of our other hosts, please feel free to ask. We have a Slack team, which I'll post the details of in just a minute. But you can ask questions at any time in the #Melbourne channel on Slack, on Twitter using the AWS Melb hashtag, or right there on YouTube in the chat, right where you're typing. And then the way we run our nights normally, at the end of each presentation, myself or Ian, my co-host, will jump on the stream with the presenter, and we'll ask the questions on your behalf. It's a great way. We prefer. It gives us a nice little chance to actually talk to the presenter rather than the presenter just reading questions out and trying to answer them on the screen. So in addition to asking questions anytime, we welcome feedback via the same channels that we mentioned before. Any feedback, positive, negative, whatever you feel like, always welcome for feedback. So, as is usual for user groups, we have sponsors in the community, and we're very grateful to our sponsors. For without their support, we would not be able to put these events on. Especially with our sponsors for 2020 and now 2021 for sticking with us through such uncertain times. So to them, we'd like to say thank you, particularly our gold sponsor Enabler, who has been with us for several years now, as well as our silver sponsors AC3, CMD, and Do It International. We really appreciate all of their support. So just a quick note on who are we, or who are we? Yeah, no, who are we? My name's Rob. I go by @Bok on most social media networks where I can. There's an underscore there on Twitter, but generally you'll find me on Slack all day anyway. And my co-host, who you'll meet in a moment, is Ian. We're members of this community, the same as you. Nobody here works for Amazon, although there are some Amazon employees as members of the community. But the good part of that is that we're not a part of Amazon's marketing arms. We can do and say what we like. We can bring whatever opinions what we like. And we love to hear what your opinions are about AWS, what your experiences are, good or bad, doesn't matter. They're all valid. They're all part of the community. So these events, this community is run by the community for the community. No one else benefits out of that except for all of us. Now, the best place to get involved in that community and to ask questions is on Slack. The details of which are on the screen there. We have, I normally look it up, But there's somewhere in the order of 500 to 600 members on our Slack team, not all of whom are active all the time, of course, but you can find people active there during the day. So it's a pretty good place to ask questions if you have any questions. There's also channels around jobs, volunteers, and we have some bots channels around AWS outages, which gets really popular when there is an outage in AP Southeast too. And there's an announcement channel with the bot that's dead at the moment, so we'll actually fix that back up soon too. But you're still more than welcome to talk about AWS service announcements, or that you're going to hear about in just a minute in the podcast. Not in the podcast, in the news segment. We do have a podcast as well, but you hear about that later on. But we do welcome, please, we want everybody to get involved. As we said, this is run by the community. So we're all volunteers here. Always looking for more volunteers to help out. And if you've ever been involved in running user groups like this before, the toughest thing we have is finding speakers. So we're always looking for speakers. We're always looking for volunteers to help running the events. Not really looking for sponsors right now, but check back with us next year. As mentioned, there's a volunteers channel on Slack if you're interested. And say hi when you come in. All right, so just a quick look around before we continue onwards. We're running a bit late now because of my technology fun times. Some other things that are on in the community at the moment. There is a new AWS IoT meetup. This is actually a global meetup rather than a local one, but it is partially run by or helped out by Tony, who presented last month, I think it was, around IoT. So it's definitely something worth checking out. They've posted their first event. I mean, it's tomorrow. I think it's tomorrow. Yep. So yeah, definitely worth having a look at that. It's online only, of course, so but worth checking out. And then finally, the data engineering meetup is on again this month, and they're very focused on AWS this month. They do cover different platforms or different cloud providers over time, but this month they're on AWS, so they're talking graph databases and AWS Neptune. And then the second presentation is around demystifying data in machine learning, which looks like a fantastic one. I definitely think I'll jump on this one in the background while I eat my lunch. URL's on the screen, go check that out. And that's all I have that's upcoming, so I will throw over to Ian and Guy, and we'll run through what's new in AWS.
Hey everyone, thanks Rob. So today again, joined by Guy, we can see right below me.
Hello.
And we're talking about all the fun stuff that AWS gave us in the past month. Always a good time.
Ooh.
So as always, we start out with finally in Sydney, which is where we discuss all the services or features that we finally have available in Sydney, where we've often looked longingly at other regions for months, and now we are glad to have them here.
Is it my imagination, or things are sort of coming to Sydney a bit quicker these days, aren't they? Do you think?
Possibly. I still often find that the ones I really want take too long.
Yep.
But anyway, on to the services. Cloud Shell is coming here, which is great. In case you missed it when we discussed it when it first came out, or haven't read about it elsewhere, Cloud Shell is basically a way to run a shell directly in your account. You don't need to spin anything up, and it comes with a bunch of disk space that you can, it's all tied to your account, and it means you can easily run your CLI commands directly
Yeah, it's really it's quite nifty. They've got it's got the CLI installed, Python, Node, and SAM. So SAM is installed there, but CDK is not. You get a gig of storage available to you, and that persists between sessions in the same region. So you sort of, once you've got a session going in a particular region, you come back to it later, your stuff will still be there, but it's per region.
So that's definitely a good one.
Yeah.
A bit more, less likely to be something you might run into is Transit Gateway Connect, which allows you to use a lot of networking stuff I'm not very familiar with to connect to certain appliances.
Yeah. And sort of for the corporate network, people who've got SD-WAN stuff already, or gear already, and they can use that to connect into AWS. So if you're in that situation, it might be worth looking at.
Yeah.
Multi-attach is cool.
Yep.
So we've got multi-attach for IO2 volumes now in Sydney. So these are cool. You can attach up to 16 Linux instances per disk, and so Linux is supported well, and Windows is not. So apparently Windows doesn't recognise the data on the volume that's shared. So you've got to watch out if you want to try and use it for Windows. But you can connect them to Windows instances too. Nitro instances only.
Yeah, but most instances these days are Nitro instances, at least the latest ones.
Yeah.
And the last one is not specifically a finally in Sydney thing, but it is for Australia. So Australian English is now supported in Transcribe custom language models. Transcribe is the service where I provided my recordings of spoken text, and it will not understand what I said.
That's pretty much how it works. I think that's what it says on the description. It will not understand what you're saying. And obviously this is designed to be more likely to pick up Australian English, spoken English than the other like when it didn't have support for Australian English. But you still have to train it. You still have to give it. You still basically have to feed it text and idioms that you use in order for it to become familiar with them. So you have to train it. So you have to get like a transcription of The Castle, that movie, so that Amazon will know, tell them they're dreaming. Those sorts of Australian slang constructs.
Yeah. Cool. Let's move on to some more other things. On the serverless side, Lambda at edge billing is now the same as regular Lambda. Used to be built per 15 milliseconds. Now it's per 1 millisecond. Always good.
Yeah, and this is especially good because a lot of Lambda at edge is doing very simple things like adding headers. So this, that's probably the most common use case for using Lambda at edge is to manipulate HTTP headers. So those operations take almost no time at all. So, being able to have that reduction in the billing increment is going to be quite a significant difference, I think, for a lot of that sort of application.
Another possibly big one is RDS for Postgre integration with Lambda. This is similar to, I think, a year ago or so when it was announced for MySQL. Basically, it allows you to call Lambda functions from your Postgres database. So if you've got, and then suddenly I'm blanking on name, if you've got user functions and such like that in your PostgreSQL, you can actually make it call Lambda to do all kinds of magic.
Yeah, so if you've got an update to a row in the database, you can fire off a Lambda that will do something with that fresh data and, send an email to somebody or whatever. Yeah, it's neat.
Another neat one here, I think, is the API Gateway Custom Domain, now supporting multiple APIs. So basically, this means that depending on the endpoint you access for the API Gateway domain, it can call different APIs. So you don't have to put everything into one giant API anymore, but you can split it up. And
yeah, so you can redirect different paths within the one URL. Basically, you can say / customers will go off to this API and / something else will go off to that API. So you can use it to kind of peel the monolith is one of the use cases they're talking about. So you can sit behind the scenes. You can break down a single sort of API into multiple services.
At this point, usually we'd switch to a container section, but there wasn't anything noteworthy really on the container side, so we'll just skip that and go straight to Dev and Ops, where one of the big news is really that Code Guru, which was the hideously expensive way to check your Java code, now is both no longer hideously expensive, and it supports Python, which today is all about. So that's great news.
Yeah, so they're saying it's up to 90% cheaper than it was before, which is a significant difference. They basically, there's a quote on their post announcing this, saying that this is the consequence of resounding feedback on various areas such as structure of pricing and language coverage. So obviously, everyone had the same reaction that we did, which was it's really expensive and it's only Java. So they've addressed both of those. So that's good. Nice to see they're responding to customer feedback.
So basically, to show how pricing changed, it went from 75 cents per 100 lines of code that was scanned to $10 per 100,000 codes in your repo. So that is a big difference. Actually, it's only $10 for the first 100,000. After that, it's $30 for every 100,000 lines of code, but that's still a massive improvement.
But we should all write less code anyway, right? Because code sucks and we're all bad at writing it. That's pretty much the universal truth, I think, isn't it?
Maybe for you. So on the other side, on the upside, a bunch of good things for CloudFormation. YAML support for CloudFormation modules. So this was before you had to write it in JSON, or what probably most people did was write it in YAML and then flip it into JSON before you committed. And you have delimiters, which makes it a lot easier to call things, or much more readable to call things in your modules. If you're not familiar with CloudFormation modules, this is basically where you provide sort of a template. You give it parameters, you call it from within your own, from within your base template, and you don't have to do all of the things. This is very useful if you have a lot of repeatable tasks. Say you have a certain way you want to structure all your S3 buckets, then you create a module for it, and instead of everybody implementing an S3 bucket having to say, I want all of these settings, you just do the one that you can just say, please use my company's S3 bucket module, which is a lot easier.
Yeah.
And some other improvements for CloudFormation.
Yep.
But keeping an eye on the time, let's move on to security.
Yep. So the Route 53 resolver DNS firewall. So that's a firewall basically between it basically firewalls the resources in your VPC that make outbound requests to the Route 53 resolver. So it allows you to limit what traffic goes between those two things. So that's a nice way of being able to kind of restrict what those resources can do at a sort of a DNS firewall level, rather than having to track it some other way. But the coolest thing is the WAF bot control, just because it's got a great name. So this is a new service that looks at metadata in the requests. So it's a WAF thing. So it looks at TLS handshakes, HTTP attributes, and IP addresses, and it will categorize the traffic as different kinds of bots, and it'll allow you to block traffic from bots you don't like. So it'll still let you keep things like crawlers, which you might want to allow to scrape your site, but to block bots that you don't like. So that's a neat new service for us webby people.
And everything with bots is fun, isn't it?
They're more than half of the traffic that you get is bots. And in fact, I think last time I looked at my site, it was probably 80% of the traffic, because nobody goes there. So all you get is bot traffic. Yeah, it's keeps the internet going, bots, these days.
Well, and then just a wrap of some other cool stuff that was announced.
Yep. The auto-scaling warm pools is good. So this is a different kind of warm instance. You can pre-initialize an instance and put it in a stop state. So that means that if the instance is kind of more ready to be added to your auto-scaling pool, because if you've got something that takes 20 minutes to spin up, you can sort of spin it up and just stop it, and then have it ready to join your auto-scaling group pool more quickly than it would be previously. Yep. So I know customers who would really benefit from that, who have horrible Java apps that take 30 minutes to bootstrap. So,
also, Aqua, which can really speed up your Redshift queries. Interestingly, this one was announced originally, I believe, at reInvent 2019, if it wasn't 2018. So that one has been quite a while in the making. It's good to see it out there. And of course, Guy, I know how much you like the Lookout services.
Yes, that's right. Of course. This is the service it's now GA. It was announced, I think, last year at reInvent. So this is it's basically a anomaly detection ML powered service that you give it your sensor data. So you have to define your sensor data. You then allow it to ingest your sensor data, and then it'll basically tell you when it finds things that look anomalous. And the purpose of it is to look for equipment failure sort of ahead of time. So it's it's a good thing. And only downside is it's only available in Europe, Seoul and North Virginia at the moment. But it'll be here soon, I'm sure.
Cool. Other one worth calling out is that SageMaker is now in the savings plan. So this is always a good thing, as you can have savings. Just keep in mind that the savings plan always looks at 24-hour usage, and I suspect most SageMaker model building doesn't. Will mostly be during working hours, but still always a good thing.
Yep.
No, I think it is time for us to start moving to the actual talks you came here for.
Yes.
Just
cool.
One last quick plug. We discuss all of this in a podcast as well. Due to my failure last month's podcast isn't actually out yet. It will be this week, I promise. My other podcast explains why I have little time often in the evenings to do podcast editing, because I've got a tiny human taking up all my free time there. But the other podcast is also all about AWS, by the way, where I use the joys of AWS to bore my daughter to sleep. And with that lovely note, I will hand it over to Rob again to introduce our first speaker. Theo.
Thank you very much, Ian. Thank you, Guy. I've made a few notes there because I haven't been keeping track of the news this month either because the bot's broken. So I'm got a few things to look up after this. All right, so our first speaker for tonight, James, if you're able to share your screen for me. And while James is doing that, to let you know that he is an avid developer who is always tinkering with different languages, frameworks, and technologies to see what's out there. Love somebody who goes out and finds things just for the sake of finding things. It's a great habit to have. James has been using AWS intensively for 4 years. 4 years straight. That's a long time. And is a certified solutions architect who develops solutions for both personal and business needs. And it looks like James is ready to go. So without further ado, I'll switch over now.
Experience for me, and I'm hoping that I can share my experience and my lessons that I've learned with you guys. So today's talk is about event-driven data using WebSockets. So just a bit about who I am. So as Rob said, I'm a solutions architect associate. I've been working with AWS solutions for about 4 years now. I'm actually a senior software engineer at Intellimatics Australia, which is a local Melbourne IT shop. I've got a GitHub page, so I've got little repos starting up every so often, little projects that I never actually finish, which is always good to hear. And obviously got a LinkedIn, but obviously this talk, I've had some help from the AWS guys, the DevX Mentor program. They've been really helpful, just sort of helping me with my talks, helping with my slides. So they've been really helpful. So stick around till the end of the talk, and you can find out how to earn some more free credits. So basically what we're going to do today, we're going to explore WebSockets, or at least as far as I have. We're going to look at the implementation of WebSockets in AWS API Gateway v2. We're then going to look at some just event-driven patterns, some really simple ones. Can get a lot more complicated if you want it to, but it doesn't necessarily have to. And then I'm just going to go through a little demo that I've actually spun up for you guys. So we'll actually use WebSockets instead of the regular sort of standard polling mechanism. So probably the first thing I wanted to go through is what are WebSockets? The word's been used quite a lot, so people kind of know what they are. People really don't know. So effectively, and this is a bit of a blurb, but it's a full duplex, which allows bidirectional connection communication. It's a protocol that allows the client and server to communicate over the single TCP connection. It's an alternative to long polling and is more based around event subscription client designs. So normally in a web application, a front end, you might be polling constantly to get data from your APIs, which is kind of more reliant on the fact of how often do you want to hit your APIs. And our WebSockets are helpful because they actually allow you to start up a TCP connection, then be able to receive data, but also send data to the server and have that, obviously that two-way highway lane, which means that you're not actually having to wait until the client has to poll to get new information. It also actually has secure socket connection abilities. You can use it using the WSS prefix. So normally with HTTP, HTTPS, you have those schemes as your way of communicating and setting up those connections. With WebSockets, it's basically just WSS. Pretty simple. So as I said before, it's really great for when you want to keep that same connection open and have that that stream of data coming up and down. So there's things like chat applications, dashboards, even game servers. They actually use it quite a lot. So under the hood, how do they actually work? And granted, this is a very simplified example. So imagine you had a server that had a WebSocket endpoint connection. And you come along and you want to make, maybe let's say it's Twitter, right? And you want to send some tweets, but you also want to receive tweets at the same time. But you don't want to have to be constantly polling for new tweets. So what happens is the client comes along, initiates the WebSocket connection. Server goes, oh, I've got a new connection. Cool. I will generate some kind of identifier to register you as this particular client. So what then happens is once that's happened, a connection is created. From then, that same TCP connection, new messages are sent, received over the same connection. So this is all happening within that one session. So that's it under the hood. But what does it actually look like in API Gateway v2? Because we're an AWS user group, we kind of want to know how to actually use these. And it sounds a lot more complicated than it is. It's actually surprisingly easy. When I first started looking into this, I thought, oh god, I'm gonna have to start managing a whole bunch of state and how do I actually send the information out. Well, the guys at AWS have actually done a very good job at trying to make it as simple as possible. So the whole API Gateway v2 WebSockets were actually announced back in December 2018. As well as the HTTP REST APIs. But how do they work? They effectively work with REST, like sort of actions sent over across the WebSocket protocol for a connect and a disconnect. And this handles like connections, right? So all you have to do is say, I want to connect and or I want to disconnect. From there, you can send actions, and this is a two-way street. So actions are sent from the clients to the server with a action in the key, and we'll go through and I'll show you through the actual console how that works. But obviously, when you're sending messages up, you want to have a default case scenario, so they have a default action. So, and the simple thing is when you actually do want to send information back down the stream, it's really simple. You can use the API Gateway Management API to send that information from your point inside the server all the way down to the client level. Pricing, because that's pretty important. I was expecting it to be a little bit more pricey than it was, but it's actually surprisingly cheap. It only costs you $1.30 USD for like the first billion requests, and then like $1.10 billion for every billion after that. So, I mean, go for it. But there is also obviously a cover charge for the connection minutes. So it's not necessarily just how many connections you actually make. It's also about how long are the connections open for, and that's priced separately, which is like 0.2325 per million connection minutes. So now that we've gone through that part, and I've just thrown a whole bunch of stuff at your face about information, a nice diagram would actually make it a little bit simpler. So what we have is we have a client, and he has an action called do stuff. And so what happens is we set up a connection with the API gateway, and the API gateway gets that message, which is just a simple JSON body. Configured in the API gateway, there's actually a route selection expression, which basically just says, when I get a key this is where I want you to get the key from. So it's simple. It's the same sort of syntax as the API gateways routing config, but you could think of this as like your REST / wherever the path is going to be. So from there, it will send it to an integration point. In this case, it might be a Lambda function. So I've routed an action, do stuff, to be connected to a Lambda function. So the Lambda function goes off, does something, and then it sends information back through the same API gateway, but through the management API, to a connection ID that is actually provided as part of the request. So when API gateway gets the initial request, it actually puts the connection ID into the request, and then allows you to send information back to the client using the management API. And this is all handled inside the Bodo library. So as Robert said, I predominantly use Python in a lot of my stuff. So this stuff is all done in Python. The Bodo library is fantastic because it actually has all this stuff out of the box that allows us to make it really simple to do. So now what I want to do is just go through some simple patterns. Again, this is not going to be too complex. I'm going to just try and just walk through a few scenarios that sort of I've discovered in my time just looking at WebSockets. And hopefully they're helpful to you guys or give you some kind of idea of how you could probably implement the WebSockets. So where I normally work in telematics, we work with a lot of event stuff. So things are happening and then triggering off stuff. And then they're just provided through REST APIs. But a lot of our stuff is we want to be able to access it in real time and then get updated in real time. So this is where it's really helpful to have that kind of stuff. One simple example for a pub sub pattern using WebSockets is the simple old chat client. The guys at AWS have actually got when they released the WebSockets or announced it, they basically sent out a quick little GitHub repo with an example, which was actually pretty handy in my understanding of how it worked. Though I had to try and translate from Node.js to Python, so that was also an experience. But all it was you had a simple API gateway connection. So imagine we've just got a client who hasn't made a connection yet, calls API gateway, right? He sends a connection request. What happens is there is a connect and a disconnect action that is inside API gateway that you always have to assign, because obviously you need to somehow cold state about what connections are where and who's actually connected to the service, and how do we actually get back to them. And that's important for pub sub, because you don't want to have to wait for a request to send information out. So what happens in the API gateway, we get a connection ID. A connect/disconnect function will handle those requests appropriately. So you can have them as separate functions, or you can have them as the same function that just deal with the logic inside. In my example, I've got a GitHub repo, so I'll have an example for you guys to go through later. But it's two separate functions, basically one for connect, one for disconnect. And all it does is when I get a connect action, I store the connection ID in a DynamoDB table. When I receive a disconnect, I delete that record. Super, super simple. So if the client, for any reason, decides to drop out internet, or they actively kill the connection, I can actually automatically update my sort of register of all the connections that I've got. So from there, let's say someone sends a message, and we've got a whole bunch of clients connected to the API gateway who are sort of listening for events. They're connected, but they're not actually sending anything. And one of our clients actually sends a piece of information. So goes all the way up, makes a connection, we get the connection ID. He then he or she sends a message, and it goes up the API gateway. Now you might have a send message action, and that's registered to a separate function. And what you can do inside that function is basically say, well, go get me all the connections, and whatever the payload of the data was, for each of the records that are inside the connection table, I want you to send that piece of information through the management gateway API to each of those connection IDs. And so what ends up happening is all the connected clients will actually receive through their connection a payload, which is pretty nifty. Oh, I've got a connections issue. So another example is sort of a backend data subscription. So initially it was chat client, so it was triggered from one front end, and everyone else received an update. But what if you really just want to have a client that sets up an initial connection and just wants to receive data? So it might be a background service, it might be anything like that, right? Oh, it could be like location data, it could be real-time updates, it could be tweets. Okay, so what we'd want to do what we did before. So it's really reusable. You can keep the same functions of connect, disconnect. So assume a client has actually set up a connection, and then you have a data source in the backend. So let's use the DynamoDB table again, and let's say there's a stream on that DynamoDB table, and that's triggering a function. And so when data gets added to that DynamoDB table, it triggers a function, and that function, all it needs to do is go, all right, what were the changes? Cool, I got this change. I'm going to send the update to all the connections inside the connections table, and then go send them all through the management API now. And it's really nifty because you can extend that to create subscriptions. So you could send extra messages up the pipe to say, all right, I've connected. I want to subscribe to a stream of data that might include locations and events and tweets, but I only really care about the locations. So I create a subscription, and then in the updated message function, you can actually filter out the information that you want to send to particular clients. So you can really create that extendability and modularity, but this is just keeping it simple, right? So what I wanted to do for you guys is to sort of actually show you this actually in action. This is so what I have is basically a demo architecture. So I'm sort of into cryptocurrency. So I kind of thought, well, those prices are always changing. I'd like to get a live feed of different markets and different places who are selling crypto at different prices, and have an auto-refreshing table that I don't actually have to constantly poll the different API endpoints to get the information. So what I did is, again, created an API gateway, created a function, created those integrations just to get the connections. Then I did the same as I did before. I had a data source. It could be the same table, could be a different table, but all this table is doing is storing the prices of cryptocurrency at a particular point in time and what the value was. And from there, hooking onto that stream of changes to pump out the information to the clients that are connected. And then all I needed to do is I've taken that pattern, which is get data, send it out, and receive data, to now the actual implementation of who is pumping information in can just go into that, can conform to a model inside the data source. And I don't actually have to worry about all the front end or implementing any new different data source implementations. I just have to write a new function that all it does is pump to that data source. So price gatherer A might go to the CoinSpot API, and price gatherer B might go to CoinGecko, and B maybe to the Binance APIs. So it allows me to trigger different polling mechanisms based on CloudWatch events, or maybe a tweet and there's an ML inside, and it's like reading, oh, this crypto coin is getting really popular now, so is the price going to go up, and all that kind of stuff. But the idea is update a data source, publish that data. Nice and simple. So what I'm going to do now is just go through, there it is. Go through my demo, which is basically just a static site running at S3. So I have this dashboard, and as you can see, it's sort of pumped out a whole bunch of information all at once. And this information has actually come from a WebSocket. So I've got a little bit of a log down here. So normally you wouldn't necessarily see this stuff, but you can see I've successfully connected. I've created that WebSocket connection. I'm now wanting to send an action up the pipe. So that's me sending an action up through to the API gateway. And once it's received that information, it's gone, oh, I need to go and just quickly refresh the information. Whatever the current state is I have, I'm going to send it down the pipe to this particular connection. So then after that, I've received all this JSON data basically down this one TCP connection of all the different pieces of information that I need. And I can use that as I want to. So I can, again, send another refresh if I want to. So I can trigger those actions as if it was a normal application. Or if I really wanted to, and I should be able to trigger, if I have a change in the backend, I should be able to invoke the Lambda manually to trigger, hopefully, a change. Oh, there we go. So you can see that it's been pushed down to me rather than I've actually asked for that information, which is pretty nifty. So from there, I can sort of just show you actually what it looks like in API Gateway. So we've seen like API Gateways console. This is just a simple API that I set up. So hopefully this is big enough. I might zoom in a little bit more just so everyone can see. So I have this API here and just called it WebSockets, right? So if we go inside here, we can actually see that it's very similar to the HTTP REST endpoints. But what we do actually see is the different route keys. So you can see we've got a connect, you've got a disconnect, and you've got, like, as I said, refresh. So from this route selection expression, so this uses when we get the actual request, we can look at the body. You can change this to a header key if you wanted to. You can change it to, well, pretty much I think that's it. But I mean, I haven't really gone that far. But I'm simply using the default, which is just a action key inside the body of the request. It takes that and then matches that up with a value inside the route key list. And so if you look at the connect, disconnect, and default, these are sort of like AWS's keywords. They're ones that you kind of have to set up. I haven't set up default because I didn't really need it, but disconnect, connect is kind of important because you kind of want to be able to resend data if you don't actually know what the active connections are. So if you look at the connect, you can see that I've set up a route request, and it just pumps off to a Lambda, and that Lambda gets executed. And all that Lambda is actually doing is storing that information inside a DynamoDB table. So what you end up with is something. I should have opened this earlier, so I apologize. Tables, go service. So you can see what I have is a connection, and this identifies what you can use to send to the API Gateway Management API to send information down to this particular client. So as you can see, I'm obviously updating prices inside inside the same table, but as prices change, I can actually get those updates in real time. So disconnect, very similar. So they just point into two different lambdas, and all this is doing is getting a lambda, getting a connection ID out of the request, which is actually part of the request. It's actually part of like the context of the request, and then you store that for later use. The alternative is that you can actually just use it. So you don't necessarily have to have the connect and disconnect. It's kind of like, well, you will use it eventually, but it's handy to actually have those integrations. The default integration, the default key is just for like if all else fails. So for some reason, you can actually, if I send through foo bar as an action key, I haven't actually registered it as an action inside the list of keys. So the default one will actually get executed. So you can return back an error response saying, go away. You haven't actually given me anything good. Yeah, and so security-wise, you can actually set up authorizers. So it's pretty standard like every other REST API. The only one thing, and the gotcha I've kind of found, is that it doesn't support API keys unless you're actually using authorizers, which is quite interesting. So the normal authorizers that you actually do have are through Lambdas, or I think JWT identity pool tokens. So yeah, just go back here. Hopefully this goes back. There we go. Yeah, so that's kind of all I wanted to show. I just wanted to give a shout out to the guys at AWS. They've been sort of helping me with like my public speaking. So any feedback that you guys have for me would be really, really helpful. In terms of if you want to give some feedback or you want to get some like in contact with the DevX guys to help with your businesses, you can use the link in the what I've got up right now, just to sort of have a look and provide that feedback. It really helps me. I've never really done as much public speaking before. I would like to learn from this and get better and hopefully present some more cool stuff to you guys later. So yeah, I guess is there any questions?
Cool. Thank you very much for that, James. That was really, really thorough and really awesome. While we wait for people to post their questions, don't forget you can post your questions in Slack or right there on YouTube as well. And I think we've got some coming through already. Queue those up. But while we do that, I've got a question for you myself.
Yeah.
Roughly how long did it take you to get up to the stage where you're at now?
I'd say less than a few hours. Like by the time I actually understood how to call, I think the longest part was actually trying to call back the API, the management API on the way back through. But yeah, easily a couple hours. By the time I learnt from nothing to actually having something working.
There's still a few hours for the amount of functionality that opens up for you. That's still good investment of time.
Yeah, and the example that I can't remember who wrote the blog, but when they announced it, it was really helpful to get started in terms of actually storing the connection IDs and deleting them, like the connect disconnect. Because I think once you get that started, it pretty much just goes, it's following the same pattern. You just got to get that connection ID. And once you get that, you can just send it to the management API. So, yeah.
Yeah, it's really useful in that it manages all of that for you, so you don't have to do any sort of connection management yourself. That takes away a lot of the pain points.
Yeah.
All right, we've had a question come in, and I guess it's more of a confirmation than a question. But it's from... Let's see if that actually shows up. No, that's not actually showing up. Pop it on the screen. It's from M. Walmsley, and I'm sorry I pronounced your username wrong. It's just a confirmation there's no usage plans for WebSocket communication stuff then.
Yeah, there aren't. As far as I can see, there aren't. You can still break it down to stages. So, but as far as I can see, there isn't really any usage plans. So I'm not sure what's like the plan with that. Be cool.
No, me either. But you did say that it actually costs a lot less than you were expecting at the start, I think. Just as it is. Cool. Well, we haven't had any other questions come through, but it looks like you've got some feedback on the chat, which I'll let you get to yourself. Oh no, hang on. Here we go. So from Stephen George, how have you managed the 1 hour timeout to WebSockets on the client? What is your keep alive method?
I did not know that. I'm learning more myself every day.
Do you have any thoughts on how you might do that? Is it just a matter of reconnecting clients, do you think?
Yeah, I believe so. So I'm using so the front end dashboard. I used Angular to the Angular framework. So I guess it's just a basic. Like I'm not a front end dev by trade. I'm actually more of a back end dev. So In terms of actually setting up client connections and holding onto them and actually doing the proper integration to make sure things are keeping alive and going. I guess I actually haven't run my dashboard for over an hour. So it's sort of, the prices are changing. I was just testing it. So it was like, oh, just keep it up for 15 minutes. Okay, it's cool. It's working. That's fantastic. But I will, if you want, I can make my repo public and have a play around with it, see if it actually does run out. If it's working, cool. I'll open up issues so you can just face PRs. I don't mind.
I guess, yeah, that depends really on the use case and what you're building and how you use it, but you can always reconnect, and if you're handling the connection and disconnection events correctly, then it would just transfer over, I suppose.
Yeah.
Cool. So in the same vein, we have a question again from M. Walmsley. Sorry again on the pronunciation. For multicast server sends, so sends to multiple clients, is it all manual via DynamoDB?
So I was thinking about this, like how you would extend it further. So when the updates come through from DynamoDB, obviously we've got a DynamoDB stream that we're listening to those and a function that's triggered off that. It does seem a little heavy-handed if you've got a lot of connections going, that you don't want one little function to actually deal with all of those connections. Obviously, your function will time out. So a potential solution to that would be that you pump it to maybe an SNS topic that would send out multiple, hey, I need you to send this message to this connection ID. And then from there, you'd have other functions or maybe another service that would actually parallelize the whole system. And so you can sort of send more information without actually overloading a function. Does that sort of help answer that?
Yeah, I think so. I guess there's two problems there. Like one, you can always filter down the list of clients you're sending to, I imagine, as well. If you put in identify action or something similar, you could then filter your targets. But yeah, I think the issue of scale there would definitely be one. If you've got enough connections at one time where you might be starting to hit timeouts on your lambdas or something like that, that's definitely going to be a good problem to have, I guess.
Yeah, and I think it comes down to that, how you architect it. If you are doing something like, if I was to do this maybe a little bit differently, I'd probably have a subscribe action that would pass in maybe a list of coins that I actually do care about, and then when the messages are sent, I'm only actually subscribing to the particular coins that I care about. So I only receive updates for those coins rather than just everything, which is what I've currently got.
Yep, cool. It sounds like there's lots of options there when you've got your different events coming in from both sides that you can control it all yourself. All right, that seems to be all we've got for now. Thank you very much, James, for that. That was really informative.
Thank you for having me on.
No worries. You're welcome back anytime.
Awesome.
All right, so moving on now. Our second presenter is Mike. Mike, if you can share your screen for me. Share your screen for me. Cool. While Mike's doing that, my presenter notes. So Mike is a solutions architect. He's pushing around boxes in PowerPoint by day. That's always the fun part of the job. But he does a little bit of code at night, and I'm guessing we're going to see some of that now, which looks really interesting. Mike looks like he's ready to go, so switch over.
Hi everybody, how are you going? What I'd like to talk to you today about is the Python serverless framework called Chalice. It's an AWS project up on GitHub. A lot of contributors to it, and I think it's been going since 2016. So today I just want to go through what it is, what appeals to me, and how you might make use of it in your own day-to-day. So that's what this talk is, a sip of Chalice. Okay. So probably one of the first things is that the Chalice is a very heavily Python library. It's all Python. And I guess one of the questions is why Python? So like I've said there, I've done quite a lot of languages, dealt with a lot of types of issues. I've written bugs in probably all of those languages, and caused race conditions and memory corruption when I can. But at the moment, I probably want to settle down a little bit and find a language that's fairly simple to write microservices in. And I came across Python when I was doing some screen scraping code, and I sort of liked the simplicity of it. I liked how flexible it was, and so then I started doing a bit more Python work. And at the moment, Python and Node.js, according to New Relic, are the top two sort of languages for building your Lambda code in. So anyway, 50% wrong, 50% right. So what I was looking for when I came across Chalice was looking for a platform that I could write and test and deploy serverless code, and support AWS Lambda was the key area, because doing architecture work in that space, and I just wanted a platform that supported AWS Lambda well. I wanted it fairly simple and not a lot of complex dependencies. When you've got multiple languages all working at once, different frameworks, things built on top of things, you get a bit tired of fixing layers on layers of software. And the other thing was looking for the Python language. So really, all of those sorts of things came together in something like Chalice. So usually I'm the guy sitting down with the beard there, with the chainmail on, and there's some other cool guy with a new hotness technology. And so Chalice was one of those areas. So I thought, well, I've given a fair few sort of platforms a go, and this framework actually turns out to be pretty cool. So I thought I'd tell you all about it. So writing serverless code, there's lots of choices. CloudFormation, using SAM, serverless application framework. That's a JavaScript-based one. There's a couple of things that are frameworks available in sort of more Kubernetes-based, like OpenFaaS and Lambduku, and there's also another Python library called SAM, Kappa, which is sort of based on SAM. And then there's Chalice, and Chalice takes quite a unique look at it, and it's a very good combination of Lambdas and AWS. So some of the key features with Chalice, this probably doesn't do it justice. It's very Python development. So you only really need Python at all to be the development platform. So it's all Python libraries. You don't need to bring in, other languages like Ruby or, Java or any of those sorts of things. So you're all working in one language. It's very simple CloudFormation deployment. It's extremely easy to get a project up and running, which I'll show you in a second. It works really great for REST web services. So if you've got a RESTful web service that you need, Flask, it operates very much like Flask. I'll show you some examples. It handles AWS events really well. So Lambda is usually able to be hooked up to a lot of different event sources, and Chalice makes it really easy to hook up to CloudWatch, S3, SQS, Kinesis, DynamoDB events. It's got great API gateway integration, and like James was talking about, we've got WebSocket support as well, so that's pretty cool. I'll show you some of that, and also great little local server development and testing environment, which makes it a lot more productive when you're building and debugging and iterating on some code. So here is a little slide that just shows how you really need to get going with Chalice. So if you've got Python on your machine, on a Mac, something like that, you should be able to do an install Chalice with one command, create a new project, call it Hello World with another command, and then Chalice deploy, and that will deploy your code straight into AWS. and it creates a little program called app.py, and there is like a little example down there below. And that's really one of the things that got me. It was actually easy to deploy and build a piece of Lambda code and get it in production. So what we might do is kind of show that in action. All right, so what I might start off with is create a new project. So we go Chalice, new project, demo, Chalice demo. Oh. Okay, just warning me about my Python version. And if we look in the directory, Chalice demo. There we go. And we've got a couple of files there. So we've got an app.py file and a requirements.txt, and we've got the Chalice directory. So what I might do now is show you what that app code looks like. Sorry. Demo, there we go, and py. Okay, so here's the pretty simple code. It imports this Chalice library. You create what they call an application. It gives it a name, and you set up a route, and that basically means anything that comes to the the root of the service. We'll call this little function here and return hello world. Yep. So what we can do is Chalice comes with a local development environment, so you can run Chalice local. Yep. Okay, and now we're sitting there running like a little local kind of version of your Lambda code, so you can develop and test on that. And then we can try it out with HTTP 127.0.18000, and there we go. So there's our HTTP header information, and our hello world comes back. Yep. So then this is where the local testing comes really great. So what we might do is we'll add this extra little function in here, and we'll get it to repeat our name. And when I save that, server restarts, and then we've got some code here. So I can do HTTP this time. I can say hello Mike. And hello Mike's coming back here. And if I change a little bit more code there, hello, I can put world Mike, save that. And restarts again, and we run that, and the change comes through. So what you can do is a fairly fast cycle, developing, testing your code, getting out working locally. It's a little bit more tricky for if you've got resources like DynamoDB, but there's kind of ways you can sort of run those things local as well. But once you're happy with that code, then what you're able to do is a Chalice deploy. Put my profile in. Oops, sorry. Wrong directory. Live demos. I was out of my mind. There we go. And we do a Chalice deploy. Now what it's doing there, it's building a SAM template, generating a CloudFormation stack, and then deploying that out to AWS. So as I fill in a bit more time, click my fingers a little bit. It creates the REST API, and now we get returned a Lambda endpoint here. So this is now our address on the API gateway. And what I'll do is I'll stop that one, and I'll HTTP, and we'll hit our actual service. So that now that's going out to Lambda on AWS. And I can put in hello Mike. And there we go. We can see the other function getting called. So that's all happened. And so it's deployed. And if we cross across to my CloudFormation, there's our stacks. With all the information, resources. So it sets up the API gateway, sets up the Lambda function, sets up roles and policies, and it's applied all that with like a pretty simple command line. So fairly simple stuff to use. Okay, and once you're finished with your function, you can basically just get rid of it with a chalice delete. And that'll clean up all your resources from the server as well. So remove the stack. So that's just a really quick example of how you can use Chalice. So hopefully it's demonstrated how it's pretty swift to get going. So here's the sort of example that we were talking about. How you build a microservice. You really can. You're configuring the application here, and then you're able to set up a set of what they call routes. And here's like a method for like getting an object, and it passes in the information for you. And also a very simple one there for putting inputs. Yep. So building a RESTful web service, all the building blocks, they're pretty easy to do. But you can also do things like scheduling Lambdas as well. So Chalice has got some nice little facilities. So in this case, it uses this little a little decorator here, which says schedule rate for 1 hour. And when you actually deploy this, it'll create a CloudWatch scheduled event, and it'll be able to call your Lambda and call this function on the time that you specify here. So it's pretty neat. It'll create that CloudFormation template and then generate it into CloudWatch and set up that resource. So if you want to quickly set up some sort of like a batch scheduled event, that's a really easy way to get the code up. Okay. Some other examples. So there's the scheduled event, also an S3 notification. You can pass in the information here, which will configure it. So here we've got the bucket name, the event that you want to target, which is objects being created in S3, and then this method will be called every time an object's created on that S3 bucket. So pretty easy code to set up, and like I said, you only have to deploy it with that one command. Okay. Some other CloudWatch examples. So something like a cloud commit, setting it up on the cloud commit events, SNS notifications, and you've got Kinesis, DynamoDB, and SQS as all event sources that you can launch these functions from, and they have a nice simple syntax for either setting the topic or the source that you're looking for. It was great timing that James was talking about WebSockets and that sort of functionality. And here is, in fact, the kind of the skeleton, I guess you'd call it, of a WebSockets application. So Chalice has got like first-class support for that one. So you set up the feature, you turn on WebSocket support, and then there's a handler for a connection when a message arrives and when someone disconnects. And you basically, that's where you put all that code in there. So it's similarly, from that one deploy command, it'll create all those handlers inside API gateway, wire them up and deploy your code. So it's a pretty simple way to build an event handler for WebSockets. And the Chalice actually have a chat application you can use as a template, and it has a DynamoDB, stores the sessions like James was saying, and sends out all the events that you can pick up, and it's quite concise. Unit testing is another area if you're into that part of the development. So you can certainly do your local test cycles fairly quickly, but if you're doing something more complex like a unit test suite, Sometimes setting up that with a server is a little bit interesting, but Chalice does have a way of being able to set up this little local gateway object. And what it'll let you do is run your test suite locally and test a lot of your code without needing to be deployed on AWS. It means it's a lot faster to go through different test cycles. And it's got a fairly simple way to build your payloads, send them through, and then validate the responses. So unit testing is quite nice. Okay. CI/CD. So Chalice does have a bit of support for, certainly, well, it uses CloudFormation scripts at the back end. So you can use Chalice Deploy to deploy it. It's great for a single user when you're doing development. You can also use Chalice to generate a pipeline. So there's a command there called generate pipeline. It gives you the starter of a CloudFormation code pipeline. It's also got Chalice CDK, which is a quick start for a CDK. So it'll let you define your application in the Python and then use Python CDK code to build the deployment for it. There's this little Chalice CDK project actually has a little quick start and builds you templates for certain different types of application structures and gives you a good quick start into getting the CDK deployment going. Chalice does use what they call has some config files for policies so that you can set up for different deployments what resources you might need to have access. So you can put a policy file with it. Unfortunately, those are files and they are not sort of like CDK native data. So when you build your CDK deployments, you need to make sure those policy files are accessible, and you sort of need to use a sort of a naming convention so that the files can be found. That's probably an area Chalice probably needs a little bit more work in some of that CDK support, but it's definitely on the way. And I've used the CDK approach with CDK pipeline, and I've also used code pipelines to build automated CI/CD stuff with Chalice, so it works quite well for those conditions. Okay, so wrapping up, well, I think Chalice, by the look of it, might be the real deal. It might be the real holy grail on making Lambda development easier. Certainly, the Python and Lambda. It's if you're into Python development, it's all sort of 100% Python tool set, so it's fairly easy to manage all your dependencies and your deployments. It's great WebSocket and AWS events support, so being able to hook into lots of different event sources. So if you need build a little batch job, if you need to build a REST microservice, all of those sorts of things are easily done with Chalice. Very simple for if you're for a single developer just doing some development work, you can use the deploy command easily. And if you're in a bit more of a larger team, then you can hook it into the more complicated CI/CD sort of pipelines as well. There's a couple of resources. Chalice, there's GitHub repo for that. There's another repo called Awesome Chalice. They have a whole range of great tools and other sort of Python libraries that work well and around Chalice. So that's a great resource. And I think you know about Lambda. Yeah. Okay, so that's probably a sip of Chalice. So any questions, I guess?
Okay, thanks for that, Mike. That was really interesting. And there have been a number of questions already. So the first one comes from some random person called Rob Amos. When you set up schedules, does it also create an API gateway? Or in other words, is the API gateway part mandatory?
Yeah, I don't. That's a great question. I haven't tried just deploying the batch only. I've usually used it as part of a larger application with a microservice. So I'll give it a try. I'll find out.
Okay. A question not related to your actual content of the talk, but Matt Delves asks, what software do you use for the presentation slides and drawing the arrows on the screen?
That is a great question. That was my purchase today when I was hoping to do the arrows. The slides are in Keynote, and I think what's it called? I'll find it. It's Demo Pro. That's it. You can find it in the Mac App Store.
Okay. Well, might definitely be something to check out because it does make it a bit easier to switch things.
Sorry. Just before you answer a question, I did forget to talk about something. So on the Chalice website, they do have authenticator integration, authorization integration. So you've got the IAM and you've got Cognito user pools already built in. So that if you use one of these commands here, it'll actually set up your authorizers for you as well on API Gateway. So that was probably picking up from James's talk a little bit.
Okay. Cool. One more question so far. Again from M. Wolfsley. Like Rob, I apologize if I pronounce it wrong. But when building out resources, does Chalice expose all the CloudFormation properties? So, for example, enabling encryption on REST on S3 buckets or making them non-public?
Yeah, I'd have to check all the configs. Certainly when you have a certain amount of config, you can set in the Chalice decorators on your different methods, but there's also a separate Chalice config file, which lets you set up a lot of different various settings. So you can change, for example, the stage name, for example. You can pass environment variables to your Lambdas as well. So you can set up environment variables inside the set up custom domain names as well. So all those sorts of configurations are probably done inside the config file. So I've used only a small sort of subset: custom domain names, environment variables, and stage names. You can set up stages for dev, test, prod, as many stages as you want, and I'll set the configuration settings for those separately. And you can also have a policy file per stage as well.
Okay, cool. I don't see any other questions, so I'll just want to thank you, Mike. It was interesting, and I definitely learned about Chalice. So I think we'll hand it back to Rob to close out the evening. Thank you.
Cool. Thank you very much, Mike. That actually makes Lambdas, particularly single shot Lambdas or really simple Lambdas, that actually takes out a lot of the boilerplate, and is probably actually how I'm going to do my Lambdas in the future. Not really a huge Python dev, even though I know I should be. But I think that's like just the convenience that you get from being able to build and test that out all locally and deploy it for a whole raft of different event sources probably wins out over the language specifically. Either way, Definitely, I will take a good look at Chalice maybe this weekend. But yeah, I think that looks really cool. I would like to give it a go. All right, so let's wrap up for the night. Our next event is the 26th of May, so again, the last Wednesday of the month as usual. Now, at the moment, this event is online again, but we are in talks with our venues to see if and when we can bring back the in-person events. So we will give you as much notice as we can if we do secure a venue and get to go back again. But for the time being, it's online. Watch this space. A huge thanks once again to our sponsors for 2021 and 2020. Enabler, AC3, CMD, and Do It International. Cannot do any of this without their support, so a big thank you for them. And a big thank you for the community as well, and for our two speakers tonight, James and Mike, for stepping up and providing such interesting talks. I've certainly learned a lot tonight, so really happy to have been here for this one. And finally, we have our post-event social drinks thing in Zoom. I will post the link in Slack in just a minute. If you've missed out on the details for Slack, there they are one last time, melbourne.awsug.org.au/Slack. I've seen a number of people have joined tonight already. Welcome along. If you'd like to jump in on the Zoom call, I'll paste the link in the general channel in a moment. Otherwise, thank you very much for watching tonight, or if you're watching on replay, thanks for checking it out. We'll be back again next month.